Yes, sir.
Right. Okay. Chalo. Good afternoon, all of you. So today we are discussing about the steel structures. So first we have to see the syllabus. What is the syllabus which is there? I will share my screen. Whether it is visible?
Yes, sir.
Yes, sir.
Right. If you see the syllabus of the gate in steel structure, there are two methods of the design that were considered. One is working stress method, second is your limit state design method. So both the methods are included in the syllabus of the gate. So in working stress method or in limit state method, you have to design the members such as tension member, compression member, beams, beam columns, column base, then different types of the connection, simple connection, eccentric connection, okay, then plate girders and trusses. All this you have to study by using both the method, that is limit state method as well as working stress method. The question कुठल्या method वरती येईल don't know, but you have to prepare for the both the methods as working stress as well as the limit state method. Okay, you have to prepare for both the method, working stress method as well as the limit state method. So which method will ask, it is don't know, but depending upon the question, the data which is given or the code which is mentioned in the question paper, so from that you can identify the methods of design, either it is working stress method or either it is a limit state method. Okay. So in your syllabus of academic, that is third year, it is working, and in your final year, okay, for final year student, it is a limit state. For diploma students, those who are completed diploma, they are already studied the limit state method. Okay, if there is a regular student, so you have to study the limit state method, okay, in detail. So this is the syllabus of the steel structure. Okay, by using both the method, working stress and the limit state method. So the question may be asked on these modules, tension member or the different members, tension member, compression member, beam columns, column base connections may be simple and the eccentric connection, then plate girder and the roof truss, and the most important, that is the plastic analysis of beams and frame. So that is a syllabus as per the gate of steel structure, right? Now, if you see the weightage, that is possible weightage for this year gate examination, expected weightage, possible, it is not confirmed. Okay, so regarding structural engineering, we are consider steel structure. So if it is a set 1, that is 5 questions. If it is a set 2, there is a 4 marks. Okay, 5 marks and the 4 marks. So if it is possible, expected, not fixed, expected, if it is set 1, the maximum mark will for the steel structure will be 5, and if it is a set 2, then it will be for the 4 marks, right? Means you have to study working stress method, you have to study limit state method, as well as you have to study the plastic analysis, and after studying it, the expected weightage in this year gate examination for steel structure may be 5 mark or the 4 mark. Okay. So which IIT will organize the gate, depending upon that, the question paper will set and the weightage of each subject will changes in each year, right? So this is the expected weightage of the steel structure, maybe for 4 marks or maximum for the 5 marks, right? So now, as per the discussion, so it is visible, PPT is visible. PPT is visible? Yes or no?
Yes,
Yes,
sir.
sir.
Right. Okay.
Yes, sir.
So as far as the steel structure is concerned, okay, if you refer the previous gate question papers, so if you refer the previous gate question papers, you will see the maximum question will ask on the plastic analysis. The maximum questions was asked on plastic analysis, maybe for 1 mark or maybe for 2 mark. Okay, maybe for 1 mark or maybe for 2 mark. If the question is for 3 marks total, 1 mark question and 2 mark total, 3 mark is for plastic analysis and remaining 1 or 2 mark for the remaining all chapters, maybe tension, compression, beam or column or basis, etc. So if you are preparing seriously, it is my personal opinion, it's my personal opinion that if you are preparing seriously for the gate examination, seriously, and if you have to crack this gate examination in first attempt, or if you have to crack this gate examination, it's my personal suggestion, it's my personal thinking that please do not go for the structural subjects. It's my personal opinion to all of you. Please do not go to the structural subject, maybe concrete or maybe steel or SM1, SM2 or mechanics of solids, etc. etc. All it includes structural subjects because weightage is maximum 10 to 12 marks and you have to prepare for 4 to 5 subjects. Applied mechanics first, mechanics of solids, structure mechanics 1, structure mechanics 2, design of steel structure, design of concrete structure, pre-stress concrete, etc. So 4 to 5 subjects you have to prepare that you have studied in your graduation level, and that will be asked for the 10 to 15 marks. Okay, so that is my personal opinion. If you are preparing seriously for gate examination, okay, please do not go to with the structural subject. I'm not talking with the steel structure. Please do not go with the structure subject because reason is that it is very lengthy. Question will ask, okay, on depending upon any data, the data may be vary, okay, but method is same. Somewhat the method is lengthy, okay. So unnecessary you are giving the time to this structural subject. So in case of that, you can give the time to the geotechnical, environment, transportation, surveying, mathematics, aptitude, etc., etc. Means you have to crack the gate examination without giving much time to this subject, that is structural subject. Okay, this is my personal opinion. So I have cracked 2 times gate examination and both the time I have not covered a structural subject, as this is my personal opinion. Okay, it is depending upon your interest, area of interest. It is depending upon area of interest, that is your area of interest. जर कुणाला स्ट्रक्चर खूपच चांगलं जमत असेल, ही कॅन गो विथ द स्ट्रक्चर सब्जेक्ट, ही कॅन गो विथ द स्ट्रक्चर सब्जेक्ट, ज्याला स्ट्रक्चर चांगलं जमत असेल त्यांनी. ओके, सो नाउ we will start this tree structure. So in that case, I am consider only first initially, that is plastic analysis. I have to discuss in brief plastic analysis for beams and Protoframes. And after plastic analysis, we will cover the eccentric connection, okay, for bolted and welded. And after that, the plate girder, okay, after that the plate girder and some portion of the roof truss and purlin. So because in 3 days, it is not possible to cover all the syllabus by using working stress method and limit state method. As you know, we have to cover in our college, that is for 3 months for one subject, 3 months for another subject, means working stress method and limit state method. Two different methods are there. So it is separate part. So if you are giving the time that is not sufficient, only 6 hours or the 5 hours for this subject, so for giving the in detail. So I am just giving the brief introduction to most important and the question which is asked in the gate examination, that I have or we have to discuss, okay, in brief. So now, what is the plastic analysis for beams and Protoframes? As the maximum questions, okay, this is already you have studied. I will not go in detail. What is the important part that I will explain with regarding the plastic analysis? So in case of plastic analysis, the question is asked on which part, that is first is your, this is the idealized stress strain curve. Idealized stress strain curve, okay, horizontal is your strain, vertical stress, and straight line, and the another line. Okay, this is called as an idealized stress strain curve. This question is already asked in the previous GATE question papers. You can refer that. You will see. This is called as an idealized stress strain curve, that is elastoplastic stress strain curve for the purpose of design only, which is not true, which is not practical, which is not true, which is not practical, but for design purpose. But for design purpose, wait, wait, I will close the door and window. There is a disturbance. I'm audible. I'm audible.
Yes, sir.
Right. So this is called as a idealized stress strain curve, which is asked many times in a GATE paper. Okay. That is for only design purpose, because we are designing the plastic design method, that is the ultimate load method. So for analysis, for the design, we have to consider this simple curve, okay, for analysis and for design purpose. Okay, wait. So this is elastic plastic stress strain curve for analysis purpose only. So this is question asked in the GATE examination. Already you know that. Now this is the plus. Now what is elastic and the plastic analysis? Elastic and the plastic analysis. What is the comparison between elastic and the plastic analysis? So these are the conditions in plastic analysis. Which are those conditions? First is called as mechanism, second is called as equilibrium, third is called as a plastic moment. So these are the three conditions of the correct plastic analysis, right? So what is mechanism? What is mechanism? Okay, when sufficient number of plastic hinges, when sufficient number of plastic hinges are formed, then structure is converted into mechanism. When sufficient number of plastic hinges will form within the structure, then the structure is converted into the mechanism. Okay. संध्या काय चॅटिंग करताय? मला पण तेच कळेना गेटचं करायचं का एंड सेम एक्झाम. ते आता तुम्ही डिसाईड करा. संध्या TB रोल नंबर 53 असते
सॉरी सर,
मध्ये.
ते फ्रेंडला करायला गेलते, एव्हरीवनला झालं.
काय काय काय
फ्रेंडला करायला गेलते सर, ते एव्हरीवन झालं म्हणे.
मग आता लेक्चर चालू आहे, लेक्चरमध्ये कशाला चॅटिंग करता? मग गेट करायचं असेल तर कशाला मग तुम्ही गेटला
सॉरी
येऊन
सर.
आलात? एनसेमच द्यायची असेल तर.
नाही सर, म्हणजे हे पण करायचं होतं, बट कुठलं मेन आहे तेच कळत नव्हतं मला.
आता ते तुम्ही डिसाईड करायचं आता. कारण आता युनिव्हर्सिटीनं तर एक एक्झाम आता 1 फेब्रुवारीपासून सुरू केली. आता गेटची एक्झाम पण 7-8 तारखेला आहे. आता ते तुमचं चॉईस आहे, तुम्ही गेट करायचं का एनसेम एक्झाम.
हा सर, ते
म्हणजे एकाच दिवशी दोन्ही
सॉरी सर.
पेपर आले तर काय करणार आता मग तुम्ही?
हा सर.
तुम्ही ठरवा. मग लेक्चरच अटेंड करायचे नाही तर गेट पण अटेंड करायचंच नाही. आता तुम्हालाच कन्फ्युजन आहे की गेट करायचं का एनसेम एक्झाम करायचं. मग तुम्ही अजून पण कन्फ्यूज आहात. आता झालं 5 दिवसामध्ये एनसेम एक्झाम आहे आणि 10 दिवसानंतर गेटची एक्झाम आहे. आणि तुम्ही ह्या मोमेंटला तुम्ही आत्ता कन्फ्यूज आहात म्हणजे आय डोंट नो व्हॉट यू आर डिसाइडेड फॉर युअर. ओके, लिव्ह इट. ठीक आहे. So mechanism is nothing but when number of plastic hinges will form within the structure, then structure is converted into the mechanism. What is plastic hinge? I will explain. Okay, next slides. Then equilibrium condition, as you know, 3 conditions of equilibrium: summation fx, summation fy, and summation of m is equal to 0. Okay, and what is plastic moment? MP. MP is nothing but what? MP is nothing but, okay, Fy into Zp. Fy into Zp, right? So that is called as a plastic moment. So these are the 3 conditions of your plastic analysis. Remember this: mechanism, equilibrium, and the plastic analysis. Okay, mechanism. Okay, number of plastic hinges will form within the structure. Okay, equilibrium, 3 conditions of equilibrium, plastic moment, MP. Then what are the correct conditions in case of elastic analysis? One is continuity condition, means deformation increase with proportional of increasing of the load. Okay, continuity connection can transmit the moment also, right? So continuity condition, if load on the beam is increasing, then deformation is also goes on increasing. That is a continuity condition, right? Then second is equilibrium condition. Sum of all the forces and moment is equal to 0. And third condition in case of elastic analysis is My is equal to Fy into elastic section modulus Ze. Right? So remember this, these are the 3 conditions of plastic analysis and 3 conditions of elastic analysis. Right? You can see from this again, plastic analysis, this black dot is indicated by the plastic hinge. Okay, that is mechanical hinge. Sorry, plastic hinge. That is mechanism condition. Second is equilibrium condition, and third is your plastic moment. In elastic analysis, continuity, if load increase, then deformation also goes on increasing, equilibrium and the yield moment. These are the conditions of your elastic and the plastic analysis. Then this is the known to you. Okay, mechanism, already I have told. This is the mechanism condition. When the system of load is applied to an elastic body, it will deform and will show resistance against the deformation. Such body is called a structure, and there is no resistance. There is no resistance against the deformation in the body. That is called as mechanism. That is called as a mechanism, right? So these are the general requirement. Already you know that in bending stress theory. Now, if you see the theory of plastic analysis, in that we have to study plastic hinge, collapse of structure, elastic and plastic moment, and the shape factor, load factor, and the collapse load. So I will go to the next part that is called as a shape factor. Okay, plastic moment. Moment can be defined as the moment which will produce full plasticity in the member of cross section and create the plastic hinges, right? I consider that you have studied already this. So I will go to the most important part, that is called as the shape factor, right? Right. Shape factor. Okay, shape factor is denoted by s, that is small s. Shape factor is denoted by small s, and which is the ratio of plastic section modulus to the elastic section modulus, or it is the ratio of plastic moment to the elastic moment. Sorry, plastic moment to the elastic moment or the yield moment, right? So shape factor, it is the ratio of ZP by JD. What is ZP? That is plastic section modulus, and JD is nothing but elastic section modulus. So ZP that we have to find out, ZP is equal to, the formula of ZP is nothing but area of the section divided by 2 in bracket y1 bar plus y2 bar, y1 bar plus y2 bar. That is the formula of your plastic section modulus. What is area? What is A? A is nothing but area of the section, and y1 bar and y2 bar, y1 bar and y2 bar. Okay, this is nothing but the, this is nothing but the, for the plastic section, you are applied the compressive force, you are applied the tensile force. So above the equal area axis, above the equal area axis and below the equal area axis, up to the centroid, whatever the distance is called as a y1 bar, above the equal axis y1 bar and below the equal axis, that is called as a y2 bar. Okay, so y1 bar and y2 bar, these are nothing but, right, the centroidal distance. Y1 bar and y2 bar, these are nothing but the centroidal distance, right? Centroidal distance above and below the equal area axis, above and below the equal area axis, right? So this is called as a y1 bar and y2 bar. Now, so for different sections, maybe rectangle section, maybe the circular section, triangular section, diamond section, I section, T section, we have to find out the shape factor. As you know that shape factor, it is the ratio of, shape factor, it is the ratio of ZP by ZE, ZP by ZE. Okay, so ZP formula as I told, okay, A by 2 y1 bar plus y2 bar. Okay, so first find out the ZP, then ZE, then take the ratio and you get the shape factor, that is nothing but S. So shape factor depends upon the material properties, okay, cross-sectional properties, material properties, cross-sectional properties, okay, that is shape factor depends. Suppose if you have taken the rectangular section, so for rectangular section, after the calculation, you get the shape factor is equal to 1.5. You get the shape factor is equal to 1.5. What is the meaning of 1.5? What is the meaning of 1.5? 1.5 is nothing but, without changing the sectional properties, without changing the section dimension, only you are changing the method of the design, that is from elastic to plastic, from elastic to plastic. Okay, for the same section, if you're changing the method from elastic to plastic, you get you get 50%, you get 50% additional capacity, or it is called as a reserve strength for rectangular section. What is 1.5 meaning is for? That is called as additional load carrying capacity or the reserve strength. Okay, that is the meaning of your 1.5. That is shape factor. 1.5 means 50% additional capacity you get by changing the method from elastic to plastic without changing the section dimension. So remember, for shape factor for rectangle section is your 1.5. is your 1.5. Then for solid circular section, shape factor is 1.7. So without changing the section dimension, you get additional 70% capacity, that is reserve strength or load carrying capacity, okay, by changing the method, that is from elastic to plastic. So for shape factor, for solid circular section is 1.7. Then triangular section is the highest shape factor, or the diamond section, okay, it is the highest shape factor, that is 2.346. It is the highest shape factor among all the section. So remember this, okay, 2.346, that is the shape factor for your triangular section. Again, you get 135% additional capacity for triangular section, but this section we are not using in the design or for erection purpose, right? Generally for I section, it is your 1.12, maximum 1.3 or 1.4, the range of the shape factor for the I section. Okay, for I section 1.1 to 1.3. Okay, so these are the different cross sections. For different cross section, the value of shape factor. You can see here ZP, JD, then the different section having shape factors. Roll steel beam section, that is nothing but I section. Okay, generally it is 1.1 to 1.3. Okay, shape factor for solid circular section, it is 1.7, right? Then for square section, 1.5, that is similar to the rectangle, 1.5. Okay, tubular tube section 1.27, triangular section 2.346, diamond 2.34, and T section 1.9 to 1.95. So these are the range of the shape factor for different cross section. Remember these values because many times it is asked in the gate examination. As I told, 2 to 3 marks questions are there, and maximum question on a plastic analysis, and maximum time it is asked on the shape factor. मॅक्सिमम वेळेस विचारलेलं गेटमध्ये क्वेश्चन आहेत ऑन प्लास्टिक अनालिसिस आणि त्यातल्या त्यात शेप फॅक्टर, आणि दुसरं शेप फॅक्टर सोडून दुसरं कुठलं असेल, फाइंड आउट द कोलॅप्स लोड और फाइंड आउट द अल्टिमेट लोड फॉर बीम और फॉर द पोर्टर फ्रेम. Okay, that is the question is asked. Now if you see, this is the gate question papers previously. Right? It is visible, PDF is visible.
Yes, sir.
Right? So if you see, this is the beam which is given. You have to find out the value of R for elastic analysis. As usual, you have studied in a SM1 or mechanics of solids. And by using plastic analysis, you have to find out the value of R by using plastic analysis. Means by using the virtual work method, okay, kinematic method or the static method, you can find out the R, support reaction, that is R. That is the one question which is asked. That is for 2 mark. Then another question on plastic analysis. This is the question on again 2 marks. Maximum time the question on steel structure is on plastic analysis. You can see now for 2 mark question. Again it is on plastic analysis. We have to find out the collapse load W. Okay. That is for 2 mark. Then somehow there is a theoretical question again on plastic analysis, 1 mark. Plastic bending beams, ratio of plastic moment to yield moment, MP by ME. MP by ME, that is called as shape factor, right? Next question is simple one question. Then you can see here Shape of cross section for largest shape factor. It is asked for 1 mark. Okay. You can say it is a diamond because it is value is 2, rectangle 1.5, I section 1.1, and solid circular section 1.7, and diamond is having shape factor is your 2, right? Again, there is a 2-mark question on plastic analysis, find out the collapse load, right? Why I'm showing to you, all of you, that is plastic analysis. Again, find out the collapse load. Again, it is for 2 mark. तर बाकीचा सिलेबस सोडला तर तुम्हाला प्लास्टिक अनालिसिसवरती तुम्हाला मॅक्झिमम क्वेश्चन्स किंवा कंटिन्युअस क्वेश्चन विचारलेले तुम्हाला बघायला भेटतील गेटच्या पेपरमध्ये. ठीक आहे. आता इथे पण क्वेश्चन आहे रिगार्डिंग प्लास्टिक हिंज. वेट फॉर 1 मिनिट. Okay, so you can see here again the question on the plastic hinge, triangular section, and for that there is a sigma y is stress which is considered here in terms of that. Okay, the question is asked, then from that you have to calculate. Then another question on plastic analysis. Right, here again, cantilever, proper cantilever beam is mentioned, and for that, what is the collapse load? That is the question. Then again, the portal frame is given here. For that, again, you have to find out the collapse load P. That is for 2 mark again. Okay, that is right. So intention behind this showing the gate questions to you that please, if you have to studying seriously for gate, then for my personal opinion, prepare for plastic analysis for steel structure. जर गेट प्रिपेअर करताय तर प्लास्टिक अनालिसिस हा चॅप्टर करा एवढा, दॅट इज ओके. बाकीचं तुम्हाला माहित असेल पण त्याला वेळ वाया घालण्यात अर्थ नाहीये. दॅट इज माय इंटेन्शन. कारण फक्त तुम्ही स्टील स्ट्रक्चर करून जाचाल आणि 2-3 मार्काला पडेल, पण त्यातल्या त्यात प्लास्टिक करा. दॅट इज इंटेन्शन. कारण तुम्ही ऑलरेडी आता लिमिट स्टेट शिकलात किंवा वर्किंग स्ट्रेस. ओके, दॅट इज नोन टू यू, राईट. नाउ shape factor that you have to find out by simple formula ZP by JD. So how to find out ZP and JD? Okay, ZP formula as I told, A by 2, Y1 bar plus Y2 bar, right? So that you have to consider. Now I will go to the next plastic hinge. What is plastic hinge? Anyone having doubt? If any doubt, please ask. Anyone having doubt, please ask. Right. Now, what is plastic hinge? Now, if you suppose, consider the beam, okay, that is simply supported beam, or maybe the cantilever beam, or maybe the continuous beam, right? So what is plastic hinge? If you apply the loading on beam, suppose W, span is AB, span is AB, L, right? So load is applied at the center, load is applied at the center. Then if you consider the parallel stress strain curve, okay, stress strain curve, if you're starting gradually apply the loading, okay, at point 1 suppose, which is direct proportional, obeys the Hooke's law, then point, at that particular point in the beam below the load, okay, some fibers are started elongating but not completely yielding. Okay, so if I draw the diagram, that is bending stress diagram, the stress is your F1, this is F1, which is less than Fy, which is less than Fy. Okay, so this is at point 1. Then if I am increasing the loading again and at point 2, that is yield point, then only extreme fiber reaches the value of Fy. So at point 2, extreme fiber reaches the value of stress, that is Fy. Stress is Fy, right? That is at point 2. Then again beyond the point 2, okay, there is a strain hardening effect, and that strain hardening is due to the ductility property, because steel is ductile material. Due to ductility property, beyond the yield point, again loading is increasing, stress increasing, strain is also increasing. So at point 3, okay, the fiber which is adjacent to the extreme fiber, they are trying to reach the value of their full capacity, that is Fy. And at point 3, in between ultimate and lower yield point, at point 3, some fibers completely yielded, that is Fy, and some fibers are not completely yielded. Means this zone is called as a plastic zone, this zone is called as elastic zone, and this zone is called as a plastic zone. So this is called as elastoplastic behavior. So some fibers it is in a plastic state, some fibers in elastic state. So it is called as elastoplastic behavior at point 3. So again, the material is having own capacity to take the load. So at point 4, that is ultimate point, below the load, all the fibers are completely yielded. All the fibers are completely yielded, and the section which is formed, that is called as a plastic section. Okay, like a 2 rectangle or the 2 square box. Okay, so this is called as a plastic section, and the new axis is called as a equal area axis. New axis is called as equal area axis. What is equal area axis? The axis which divides the plastic section. This is called as a PS, plastic section. The section which divides the plastic section into two equal areas, that section is called as plastic section, and the axis which divides the plastic section into two equal area, that axis is called as equal area axis, right? So this is called as a plastic section, and below the load, all the fibers are completely yielded, and there is a zone is called as a yielded zone. That zone is called as yielded zone. And this is treated as a plastic hinge. This is treated as a plastic hinge within the structural member. What is yielded zone? Yielded zone is nothing but where each and every fiber below the load, where there is a bending moment, that moment is called as a plastic moment. Right? So below the load, there is a moment that is called as a plastic moment, because section is plastic section. Moment is your plastic moment. below the load, each and every fiber below the load, each and every fiber is completely yielded. Completely yielded is nothing but they're reaching the value of their full capacity, that is Fy. Each and every fiber having full capacity, that is Fy. Okay. So each and every fiber is completely reaches the value of Fy. That zone is called as yielded zone, and that zone which is denoted by black dot, and that black dot is treated as plastic hinge. That black dot is treated as plastic hinge. Okay, so this is regarding the plastic hinge. So where the plastic hinges will be formed? So plastic hinges will be formed. One is below the concentrated load, below the concentrated load. Okay, means if you consider the beam, then apply the load, then below the load there is a maximum bending moment. So exactly below the load, there is a plastic hinge will be formed. PH, plastic hinge will be formed. Okay, second, at fixed support, at fixed support, at fixed support means if you consider the fixed beam, okay, there is a moment at fixed end. So whenever there is a bending moment, there is a plastic hinge. Whenever there is a bending moment, then it is considered as a plastic hinge MP. Moment is MP. Okay, moment is MP. Whenever there is a moment, that is MP, there is a plastic hinge. Okay, so at fixed support, there is a bending moment. So moment is MP, and at that particular point, plastic hinge will be formed. Third, where shear force is 0, okay, when there is shear force is 0, in case of continuous beams, okay, depending upon the loading, okay, due to the continuation of support, at some point there is no bending moment is maximum, but the shear force is 0, okay, somehow, but by considering the maximum moment in all three spans, I'm not talking about this separate span, okay, somehow there is a shear force is equal to 0. At that point also, there is a plastic hinge will be developed, right? Then where moment of inertia changes, right? Whenever the moment of inertia changes, at that particular point also the plastic hinge will form. If suppose there is a prismatic beam is there, means the moment of inertia is 2I, and for this moment of inertia is I. Okay, at that particular point, the moment of inertia is changing from 2I to I. So at that particular location, there is a plastic hinge will be formed. Okay, these are the some locations where the plastic hinges will be formed, right? So plastic hinge and mechanical hinge. Mechanical hinge is nothing but the hinge support or the roller support, hinge support or the roller support. Okay, that is mechanical hinge. That is mechanical hinge, which is seen by naked eye, real, right? And mechanical hinge, that is hinge support, at that particular support moment is equal to 0. Moment is equal to 0. And plastic hinge is a concept, it is imaginary, which is not seen by the naked eye. Okay, concept, right? Hinge, plastic hinge, that is concept, imaginary, which is not seen by naked eye. And at plastic hinge, the moment is nothing but your plastic moment, that is the MP. Okay, mechanical hinge, moment is 0, and at plastic hinge, moment M is equal to MP. That is your plastic moment, MP. So you can see here the plastic hinge, black dot. Plastic hinge is denoted by the black dot. 1, 2, 3, 4. These are the different point where you can take this section. This is a plastic hinge, right? The beam is separated into two parts. after the plastic hinge will form. You can see here fibers are completely yielded, then it is called as a plastic hinge. Plastic is defined as yielded zone due to the bending in a structural member at which the infinite rotation. Plastic hinge is nothing but yielded zone due to the bending in a structural member at which infinite rotation can take place at a constant plastic moment, MP, right? So this is regarding your plastic hinge, right? This yielded zone, hinge length. Remember, for simply supported beam, okay, how much will be this hinge length? Plastic hinge length किती असणार आहे? Okay, suppose I am calling as X. So how much will be the length of the plastic hinge in case of simply supported beam? So it is your L by 3. What is X? As I told, is nothing but is the length of your plastic hinge, X. So for simply supported beam, hinge length is L by 3, and if it is a simply supported beam subjected by UDL, so it is L by root 3. ठीक आहे. सिम्पली सपोर्टेड बीम असेल आणि पॉइंट लोड जर असेल तर हिंज लेंथ इज इक्वल टू 1/3 ऑफ स्पॅन ऑफ बीम, आणि जर तुमचं युडीएल असेल तर हिंज लेंथ इज इक्वल टू L by root 3 येतं. ओके, सो रिमेंबर दिस टू. हाऊ इट इज कॅल्क्युलेटेड? दॅट इज सिम्पल मॅथमॅटिकल कॅल्क्युलेशन. ZP, okay, A by 2 Y1 bar plus Y2 bar, that is your section modulus ZP. Now going towards the load factor. Okay, load factor is nothing but it is the ratio of collapse load to the working load. Okay, collapse load is nothing but your ultimate load divided by working load, WW. Okay, or MP by M. Okay, MP is nothing but the plastic moment and M is nothing but your working moment or elastic moment. So MP is sigma Y or Fy into ZP divided by sigma into Z by taking the I section. Okay, suppose taking 1.15 is the shape factor for I section, that is for beam. You get load factor is equal to 1.7. By simplifying, you get 1.7, that is the load factor. Okay, for the beam, that is the I section, right? And the rectangle असेल तर 1.5 भेटेल. ओके, जर तुमचा आय सेक्शन असेल तर 1.7 इज द लोड फॅक्टर. ओके, so mechanism already I have discussed. Again I will repeat this. Mechanism is nothing but there is no resistance against the deformation in the body, then it is called as a mechanism condition. कोणाला काही डाऊट आहे का प्लीज विचारा, मी बोलत चाललोय. कोणाला काही डाऊट आहे का? Anyone having doubt? Or shall we take some questions and then we will proceed? काही क्वेश्चन्स घ्यायचे का? नंतर मग पुढे गेलं तर चालेल का? प्लीज रिप्लाय.
सर लोड फॅक्टर आणि शेप फॅक्टर मध्ये काय रिलेशन आहे का सर?
लोड फॅक्टर आणि
शेप फॅक्टर मध्ये काय रिलेशन आहे का सर?
एक मिनिट. Shape factor is equal to what? MP by, sorry,
MP by MY.
MP by MY, and load factor F is nothing but it is MP by your ME, elastic moment, right? तर इथं काय तुमचं शेप फॅक्टर मध्ये FY ZP असतं आणि इथं FY आणि ZE आहे. आणि लोड फॅक्टरमध्ये काय येतं, इथं FY ZP आणि इथं खाली F येतं, परमिसिबल स्ट्रेस इंटू ZE. राईट. शेप फॅक्टरमध्ये वरती जर बघितलात तुम्ही तर दोन्हीकडे तुमचा यील्ड स्ट्रेस आहे, पण लोड फॅक्टरमध्ये जर बघितलात तर इथे तुमचा FY/F आहे. काय म्हणतो लक्षात येतं मी?
येस सर.
तर त्याप्रमाणे इथं परमिसिबल स्ट्रेसची व्हॅल्यू आपण पुटअप करतो आणि इथं तुमचं FYच असेल. बाकीचं मग तुम्हाला इथं जर हे घेतलं ZP/ZE तर इथं लोड फॅक्टर F इज इक्वल टू, तर फक्त आपण जर इथं जर शेप फॅक्टर घेतलं तर FY/F इंटू शेप फॅक्टर, हे रिलेशन तुम्हाला याच्यावरून भेटेल. ठीक आहे.
येस सर. थँक्यू सर.
आता FY ची व्हॅल्यू मी ॲज इट इज ठेवला आणि आता समजा मी आय सेक्शन घेतला किंवा मग बीम घेतला, बीमला मी 0.66 FY घेतोय, बरोबर. FY बीमला परमिसिबल स्ट्रेस आणि इथं शेप फॅक्टर तुमचा यस आहे, तर इथं FY गेट कॅन्सल, तर F इज इक्वल टू काय येईल इथं 1/0.6 म्हणजे जवळपास 1.515 काहीतरी येईल मल्टिप्लाय बाय शेप फॅक्टर. तर अशाप्रमाणे हे तुम्हाला रिलेशन भेटेल. मग ते आता तुम्ही बीम यूज करताय किंवा अदर टाईपचा मेंबर, टेन्शन मेंबर वगैरे यूज करताय, त्याप्रमाणे तुमचा हे रेशो चेंज होईल. ओके.
येस सर.
राईट. अजून कोणाला काय डाऊट? हां, चॅट बॉक्समध्ये काहीतरी होतं. हां, येस, क्वेश्चन घ्यायचे काही? दंडगल. ठीक आहे. Wait. We will take a question on shape factor. Check whether you know that or not. Now you can see here. Okay, I will share first. It is visible? It is visible?
Yes sir.
Now, question number 27. The shape factor for a solid circular section of diameter D is equal to. So can anyone tell me? Shape factor for the, yes please.
Option C.
Option C. That is nothing but 16/3 pi. Correct? Yes?
Yes sir.
Right, correct. Okay. That is 16/3 pi. That is answer. Now, next question is that load factor to be used for plastic design of steel structure for dead load and live load is F, as I told on the white screen also. Please reply.
1.5.
किती येतं?
1.5.
Okay. It is as per the dead load and live load, it is 1.7 as per the code. If you refer the IS 800 1984, section number 9, plastic analysis, you can see the table. In that particular table, for dead load and the live load, it is 1.7. Okay, that is for, this is for the beam, that is I section. For rectangle section, it is 1.5. But in the code, minimum value is mentioned is 1.7. Minimum value is mentioned, it is 1.7 in IS code. So answer is your 1.7. Now the next question is that, question number 29. The structure has 2 degrees of indeterminacy. The number of plastic hinges that would be formed at a complete collapse is equal to. R is equal to 2i. So what is number of plastic hinges N is equal to?
2.
2. Anyone other please?
1.
1. अरे यार आज करू नका.
3 sir, sorry, 3. R plus 1.
हाँ R+1 है ना फॉर्मूला N चा. Number of plastic hinges is equal to R+1. R is nothing but degree of static indeterminacy. R is degree of static indeterminacy and plus 1. So 2 plus 1 is equal to 3. So answer is your D. Right? गड़बड़ करायची नाही. Now the question is that this commonly asked the question, what is the shape factor for rectangle section?
1.5.
1.5, that is B, correct. So again, the question. Question number 42. Question number 42. Which of the following diagrams correspond to the load deflection characteristics or the moment curvature relationship up to the plastic collapse of the beam shown below? Load deflection or moment curvature relationship. So which diagram is correct for corresponding to the load deflection characteristics up to the plastic collapse? तर पहिली डायग्राम बघा, सॉरी फिक्स बीम आहे, फिक्स बीम आहे, पॉइंटेड ॲट सेंटर आहे. तर ह्या बीम साठी तुमची लोड डिफ्लेक्शन डायग्राम कुठली असेल, दॅट इज अ क्वेश्चन. क्वेश्चन नंबर 42. तर मध्ये पहिलं डायग्राम अशी आहे बघा, लोड आहे डिफ्लेक्शन आणि पॉइंट पी पासून हॉरिझॉन्टल लाईन आहे. नंतर सेकंड डायग्राम अशी आणि अशी आहे. थर्ड डायग्राम हे आणि हे, चौथी अशी आहे. तर 4 मधली कुठली बरोबर आहे?
B.
D.
डी का बी?
B sir, B.
सेकंड का फोर्थ? सेकंड का फोर्थ?
Second.
सेकंड, दॅट इज लो डिफ्लेक्शन किंवा मोमेंट कर्वेचर. मी आताच म्हणलं होतं की आपण प्लास्टिक अनालिसिस मध्ये सिंपल डिझाईन करण्यासाठी आपण स्ट्रेस स्ट्रेन कर्व घेतो, दॅट इज आयडियलाइज स्ट्रेस स्ट्रेन कर्व. आयडियलाइज स्ट्रेस स्ट्रेन कर्व, राईट. सोल्युशन विच इज देअर. नंतर इथे या 1-2 क्वेश्चन घेऊ, देन वी विल प्रोसीड फॉर द कोलॅप्स मेकॅनिझम. इथं कोलॅप्स मेकॅनिझम आहेच, मॅक्झिमम टाइम विचारलेला क्वेश्चन आहे. माझ्याकडे आता रेकॉर्डेड व्हिडिओ आहे, 5.5 तासाचा आहे. ते मी आणि मटेरियल पण तुम्हाला गुगल ड्राईव्हची लिंक शेअर करेन, त्या ग्रुपवरती TAB असेल. ठीक आहे. द क्वेश्चन अगेन इज नाउ शेप फॅक्टर इज द आन्सर. अगेन सेम क्वेश्चन, रेक्टँगल सेक्शन, बहुतेक तेच आहे, गेटचेच पेपरचा आहे. ठीक आहे. अगेन सिम्प्लिफाय दिस. कॅल्क्युलेशन करावं लागेल. आय विल नॉट गोइंग टू दॅट पर्टिक्युलर पार्ट. कॅल्क्युलेशन करूनच तुम्हाला करावं लागेल. ठीक आहे, लिव्ह इट. सो आय विल गो टू द नेक्स्ट पार्ट, दॅट इज various types of independent mechanisms. Various types of independent mechanisms. So there are different independent mechanisms: beam mechanism, sway or the panel mechanism, gable mechanism, joint mechanism, and the combined mechanism. So how we have to find out independent mechanisms? So small n is equal to capital N minus R. Capital N is nothing but the possible locations of plastic hinges. And what is R? Degree of static indeterminacy. What is R? Degree of static indeterminacy. So what is small n? So how much independent mechanisms are there, that we have to find out depending upon the value of capital N and small r, right? So as you know, number of plastic hinges is equal to R plus 1. Chart box. So I am talking about the independent mechanism. So if we have to consider the Protoframe, and the column having both the ends are fixed. So this is A, this is your B, this is your C, and this is your D. On beam BC, load is applied at center W, and at the joint, again load is applied as W, right? Now joint B and joint C, these are treated as a rigid joint. Joint B and joint C are treated as a rigid joint, that is treated as a fixed end. Joint B and C are treated as a rigid joint, that is treated as a fixed end. Okay, so now how we have to consider the independent mechanisms, or how we have to find out the independent mechanisms? AB is column, CD is column, BC is your beam. So what is formula? Small n is equal to capital N minus R. Okay, capital N minus R. For beam BC, we have to apply the beam mechanism. And for ABCD frame, we have to consider the sway mechanism or the panel mechanism. Okay, ABCD sway or the panel mechanism, and BC is the beam. Okay, so it is considered as a beam mechanism, right? So where the plastic hinges will form, can you tell me possible locations where the plastic hinges will be formed? At which locations? Yes, please.
B, below the point load, and C.
Okay. Where? You can repeat, please.
At B,
At B.
B,
Okay. Then
below the point load,
below the point load
at C.
at C. At A and D, E आणि D ला येत नाही का? There are 5 possible locations of plastic hinges. One is at A because fixed end moment is there. B, C, D, and below the load. So there are 5 possible locations where the plastic hinges will be formed. And can you tell me what is value of R is equal to? What is value of R is equal to?
3.
3. How it is 3?
6 minus 3.
6 minus 3. 6 is nothing but 3 unknowns at support A, 3 unknowns at support D, minus 3 equations of equilibrium. So you get R is equal to 3. So number of independent mechanism, capital N minus R is equal to, for this frame, 5 minus 3 is equal to 2. So 2 independent mechanisms are, first is your beam mechanism, and second is your sway mechanism. Okay, beam mechanism is for beam BC, sway mechanism is for frame ABCD. And by combining both these two, beam and sway, the third mechanism is called as combined mechanism. Third mechanism is called as combined mechanism. Okay, so remember this. So depending upon the end conditions and loading, find out the possible locations of plastic hinges capital N, then find out R, then take the difference n capital N minus small r, you get number of possible independent mechanisms. So whatever the value of small n, that nothing but the independent mechanisms are required. So for this case, fix end at A and D. So and load is at the center on beam BC. So there are two independent mechanisms. One is beam mechanism BC and second is sway mechanism for ABCD frame. So if I consider, that is a question to all of you, if this is the case, this is suppose fix n, this is your hinge, load is applied here, load is applied here, right? This A, B, C, D at E and F. This is your W1, this is your W2. So can you tell me capital N is equal to? Capital N is equal to possible locations of plastic hinges. Yes, please.
3. 3, sir.
Capital N is equal to 3.
5.
5, sir.
5. Where?
A, F, B, E, C.
A, B, C. These are the point. A fixed end आहे, B ला सुद्धा rigid, C is also rigid. So A, B, C. Then next कुठले कुठले point म्हणलात?
E and F.
E and F below the load W1 and below the load W2. N is equal to 5. What is R is equal to?
2.
5 minus 3. 2. So small n, number of independent mechanism is equal to 5 minus 2 is equal to 3. So which are the three independent mechanisms?
2 beam mechanism and 1 sway mechanism.
Correct. Okay. Two beam mechanism, that is beam mechanism for beam BC, beam mechanism for beam AB, and sway mechanism for A, B, C, D. Correct? Yes or no? And along with that, there is a combined mechanism. Along with that, combined mechanism. So there are two combined mechanisms again. Okay, combined mechanism, one A, beam BC and frame ABCD, and second beam AB and frame ABCD. Okay, so combined mechanism घेताना एक BC चं beam BC आणि frame घ्यावं लागेल. फ्रेम घ्यावं लागेल आणि सेकंड याला कंबाईनला बीम आणि तुमचा फ्रेम असेल. फ्रेम आणि बीमचं कॉम्बिनेशन घ्यायचं कंबाईन मेकॅनिझम घेताना. ओके, सो दिस इज नथिंग बट युअर independent mechanisms. So next is the methods of plastic analysis. Method of plastic analysis. That is the last part that I have to discuss for today's session. Okay. Method of plastic analysis. There are two methods. One is called as a static method and second is called as a kinematic method. Okay, two methods in plastic analysis. One is static and second is kinematic. So I will tell one by one what is static and what is kinematic. So first is static. It is not possible to cover this chapter in 2 hours, as you know, all of you. So I am covering only the main important part. You have to practice at your own. If any difficulty at any time, you can ask. Okay. So now I have considered the simply supported beam. simply supported beam. Load is applied at center W. Okay, span is your L. Span is your L. Right? Suppose this is your A, B, C. Now, in case of static method, what we have to find out? We have to find out collapse load, WU, or you may call it as WC. Okay, WU ultimate load or WC collapse load, or we have to find out plastic moment. तर तुम्हाला क्वेश्चन्स काय असणार आहेत? क्वेश्चन्स काय असणार आहेत त्याच्यावरती स्टॅटिक मेथड किंवा कायनेमॅटिक मेथडवरती? तर तुम्हाला डायग्राम दिले जातील, त्याप्रमाणे तुम्हाला एकतर कोलॅप्स लोड फाइंड आउट करा म्हणून सांगितलं जाईल आणि किंवा प्लास्टिक मुवमेंट. कोलॅप्स लोड कधी फाइंड आउट करता येईल? ज्यावेळेस तुम्हाला स्पॅन दिला जातो आणि तुम्हाला कोलॅप्स लोड इन टर्म्स ऑफ MP प्लास्टिक मुवमेंटमध्ये व्हॅल्यू भेटेल. ठीक आहे, कोलॅप्स लोडची व्हॅल्यू इन टर्म्स ऑफ सम फ्रॅक्शन ऑर सम व्हॅल्यू. ठीक आहे, आणि मोमेंट फाइंड आउट करताना लोडची व्हॅल्यू दिली जाईल. तिथे तुम्हाला डायरेक्टली प्लास्टिक मुवमेंटची व्हॅल्यू भेटून जाईल. तर हे स्टॅटिक मेथड किंवा कायनेमॅटिक मेथड यूज करून तुम्हाला काय फाइंड आउट करायचं? एक तर अल्टिमेट लोड और कोलॅप्स लोड और अदर यू टू फाइंड आउट द प्लास्टिक मुवमेंट. राईट? आणि एक लक्षात ठेवा, कोलॅप्स लोड घेताना मिनिमम घ्यायचं आणि प्लास्टिक मुवमेंट घेताना मॅक्झिमम व्हॅल्यू घ्यायची. रिमेंबर? ओके, वेन यू टेकिंग द नंबर ऑफ इंडिपेंडेंट मेकॅनिझम्स, तुम्ही बी मेकॅनिझम्स वे घेताय, कंबाईन घेताय, तर सगळ्यांचं ज्यावेळेस तुम्ही व्हॅल्यू कम्पेअर करताय तर तिघामधली जी सगळ्यात मिनिमम व्हॅल्यू जी असेल कोलॅप्स लोडची व्हॅल्यू, तेच तुमचं फायनल आन्सर असेल. आणि तिन्ही मेकॅनिझम जर तुम्ही कम्पेअर केलात, बी इन स्वे आणि कंबाईन, त्यामध्ये प्लास्टिक मुवमेंट जर फाइंड आउट करायला जर विचारलं तर तुम्हाला सगळ्यात मॅक्झिमम व्हॅल्यू घ्यायची तिन्ही मेकॅनिझम मधून. सो व्हॉट यू हॅव टू डू इन अ स्टॅटिक मेथड? ठीक आहे, तर स्टॅटिक मेथडमध्ये सिंपल काय, पहिल्यांदा डायग्राम दिली जाईल, त्यासाठी तुम्हाला बेंडिंग मुवमेंट डायग्राम ड्रॉ करायचे. सिंपल. तिथे व्हॅल्यू लिहायची. व्हॅल्यू आहे WL/4 आणि W ला आता रिप्लेस काय असेल, मी WU करतोय, कोलॅप्स लोड. ओके ओके, that is the maximum bending moment. And this maximum bending moment, that we have to equate to the plastic moment MP. तर कारण तुम्हाला माहित आहे मॅक्झिमम बेंडिंग मोमेंट आहे तिथं तुमचं प्लास्टिक हिंज फॉर्म होतो. प्लास्टिक हिंज जिथं असेल तिथं मोमेंट काय असतं? प्लास्टिक मोमेंट. सो मॅक्झिमम बेंडिंग मोमेंट दॅट वी हॅव टू इक्वेट टू MP इन विच मेथड? स्टॅटिक मेथड. स्टॅटिक मेथडमध्ये काय करतोय आपण? बेंडिंग मोमेंट maximum equate to MP. So maximum bending moment is equal to WUL/4 is equal to MP. So I have to find out collapse load. WU is equal to 4MP/L. That is the answer. Remember this. Simply supported beam subjected by point load at the center. So for that, collapse load is equal to 4MP/L. This is by using static method for simply supported beam. Right? Now again, for same static method, if I consider fixed beam, static method is use करतोय मी, static method use करतोय. Fixed beam, load is applied at the center, W. So for this case, first step is that remove the fixed support, make the beam determinant. Okay. Remove the fixed support, make the beam determinant. Okay. Then draw the bending moment diagram for this. This again WUL/4. Then second step, consider the fixed end only without any load. For that, draw the bending moment diagram. And this fixed is moment that we have to consider is equal to MP. Okay, then these two diagrams we have to combine like this. So this is called as a combined BMD. This is called as a combined BMD. Okay, this is your WUL/4. This is your MP, right? So now, as I told, maximum bending moment is equal to MP. So now WU L by 4, there are, sorry, is equal to MP plus MP, two plastic moment. So WU L by 4 is equal to 2MP. So what is the collapse load for the fixed beam subjected by point load? It is equal to 8MP by L. Remember this value again. Fixed beam subjected by point load at the center. So collapse load here, W is equal to 8MP by L. So this is the static method. This is the static method. If I consider the same beam काय fixed beam घेतोय मी. सेम आता लास्ट याला 8MP by L घेतलं ना, तर तेच बीम घेतोय मी. Now I am using the second method, that is kinematic method. Kinematic method. So for this method, I have to use the principle of virtual work. Suppose this support A, B, fixed support, and C, span is your L, this is your L by 2, L by 2. So now, first we have to find out R. What is R is equal to? Can anyone tell me for this case? Yes, please.
2.
2.
Yes, sir.
4 minus 2, correct. That is 2. Why it is 4? Because there is no horizontal load, so we are not considering the horizontal reaction here. So vertical 2 and 2 moment 4 minus 2 equation Fy and M. So we get R is equal to 2. So number of plastic hinges is equal to how much?
3.
3. R plus 1 is equal to 3. So where these the plastic hinges will form?
A, B below the point load.
A, B and below the point load, correct. So now A, B and below the point load. So plastic hinge always shown by the black dot. Remember this. Plastic hinge always shown by the black dot. So this is called as a beam mechanism diagram. Load is applied at the center. That load is I have considered as a LWU. Span is your L by 2, L by 2, L by 2, L by 2. And there is an imaginary displacement that is called as a delta by using principle of virtual work. Delta is imaginary displacement which is below the load. Okay, then there is a friction, therefore there is a plastic moment MP, there is a plastic moment MP, right? Then there is a plastic hinge, therefore plastic hinge will rotate at infinite rotation theta, that is angle of rotation, that is called as a theta. This is a theta, opposite angle theta. So at below the load there is a 2 theta, theta plus theta, 2 theta. Then there is a moment again where the plastic hinges will be formed. There will be the always moment that is called as a MP. So this diagram is called as a beam mechanism. This diagram is called as a beam mechanism. This diagram is called as a beam mechanism. Okay, so now for this beam mechanism, can anyone tell me for this small triangle, tan theta is equal to delta divided by L by 2, correct? So delta is equal to
Yes.
L by 2 into theta, as tan theta is very small. So we have to consider theta. So delta is equal to L by 2 theta. Delta is below the load, that is imaginary displacement. is equal to L. L is span by 2 into theta. Remember this value, right? Now, while you applying the kinematic method, while you applying the kinematic method, use the principle of virtual work is nothing but external burden is equal to internal burden. What is principle of virtual burden? Okay, what is principle of virtual work? External burden is equal to internal burden. So in case of plastic analysis, external burden is due to the applied load. External burden is nothing but the applied load is nothing but the load multiplied by the delta, load into delta, and internal burden is due to the MP. Internal burden is due to the MP in case of plastic analysis. Okay, in case of plastic analysis, internal burden is due to the MP. So internal burden is equal to MP into theta, that is rotation. So this is the principle of virtual work that we have to apply in which method? Kinematic method. Okay, so external burden is equal to internal burden. External burden is equal to W into delta is equal to MP into theta, that is internal burden. So WU into delta is L by 2 into theta is equal to MP at A, at B, and at C. So MP into theta at A plus MP into theta at B plus MP theta plus theta at C. So is equal to 4 MP theta is equal to WU L theta by 2. Theta theta get cancelled. So collapse load you get 8 MP by L. As we have discussed for static method, answer is same for fixed beam subjected by point load at the center. So WU is equal to 8 MP by L. That is a collapse load for fixed beam subjected to the point load at the center. Wait. हाँ सर जी. Okay, it is understood. समझलं का हे? Yes or no?
Yes, sir.
Right.
Yes, sir.